Hi, and welcome to our third video in this series on basic trigonometry. And what we're going to be doing in this video is just taking the skills that we saw from the previous two, sine rule, cosine rule, and all that kind of stuff, and applying them in context, and in particular chucking in some stuff to do with bearings as well. So here we go. First example, so you can read the question for yourself. You've got a couple of yachts, and we've got some information about where they're located relative to a lighthouse. So first thing to do with this is just to kind of take that information from the question and turn it into a diagram. So I've got my lighthouse. Quick reminder, bearings measured from north and always measured clockwise. So there's a bearing of 054, 24 kilometers away, and there's my first yacht A. And then we've got the north line from that one, and we're saying the bearing of B from A is 203, so we've got to go clockwise all the way around, and so there is yacht B. So that's what we're looking at, and what we need to do is find the bearing of yacht B. So we've got to find the bearing of this point here from our lighthouse, and also how far that distance is from A to B. So first part of the question, we need the bearing of B from the lighthouse. So that's the one that we're looking at, and we know it's 18 kilometers, and what we've got to do is figure out what the bearing is. So essentially what we need is that angle there. So we've got the 54, so clearly we're going to just need the size of the angle in the triangle there. Right, so we haven't got a whole lot of information in that triangle at the moment. We know two sides, but we don't know any of the angles. So let's see what we can figure out. Let's start having a look at A. First thing we're going to do is just have a look at that angle there. And just a quick recap of what you remember from GCSE about bearings, north lines, allied angles, and all the rest of it tells us that X is 126 degrees. So that angle there is 126. And so putting that together with the information that we've got up here, 126, 203, that means that that angle there has got to be 31 degrees. Now, as soon as we know that, we can see that what we've got there is a pair of opposite side and angle. So that means we're going to be able to use sine rule. So here we go, let's do a bit of sine rule, and let's say we'll do it to find this angle down here. So we need sine of that angle over 24, again putting the angles on the top because that's what we're trying to find, is sine 31 over 18, and that pops LBA, that angle there is 43.4 degrees. And so if we know two of the angles in our triangle, so we've got those two angles, clearly that means we're going to be able to find this one now, so that's fairly straightforward. So that means that one there is 105.6. And so, of course, the thing we need, which is the bearing, which was all of this red angle, is going to be 54 plus the 105.6. So therefore, we've got our bearing, which is 159.6 degrees. So that's the first bit of the question done. On we go. Second part of the question is asking for the distance between yachts A and B. So that's that distance there. But if you look at this now, we've got all three angles, we've got two sides, so realistically we've got a choice of what we want to do. So I'm just going to go for cosine rule on this one. So we'll just chuck the values into the cosine rule. There it is. AB squared, 24 squared plus 18 squared minus 2 times 24 times 18, cos 105.6. So there you go, there's 105.6. Remember, we're finding that opposite side there. And so that gives us AB is 33.7 kilometers. Job done. Right, on to the next one. Now, this one, a very different kind of example. This one, I actually nicked this from, came from the top end of a GCSE paper, and it is a real shocker. But it's a real good question in terms of asking to think and apply your trigonometry skills. So let's have a look. So what we've got is that hexagon. We've got A, B, C, D, E, F, and then 2 points P and Q. And we've got some information about the size and A, B, C, so the angle at the top. So that angle there is 30 degrees, and we've got to prove this fact here, which looks horrible, but let's just see how we go. So let's start off with triangle PBQ. So that's the triangle going from there to there to there. And the reason I picked that one is because it's the cosine of PBQ, i.e. this angle here, that's the thing I'm trying to find. So let's kick off with cosine rule. So we've got PQ squared, so the opposite side squared is 10 squared plus 10 squared minus 2 times 10 times by cos PBQ. And because we want this thing, what I'm going to do is rearrange it to make PBQ the subject. So, bit of tidying up, bring the 10 squares to make 200, 2 times 10 times 10, that's 200 as well. And a little bit of rearranging, and there we go, we've got an expression for cos PBQ. which is the thing that we're trying to find. Now, the thing I'm noticing now is we've got this 200 that's appeared on the bottom here. We can see that's appeared there. But you can see here it's negative, here it's positive. So what I'm going to do is just to make life a little bit simpler and try and get my result to look something like where I'm heading towards, I'm just going to take this minus 200 and turn it into a positive 200. So I'm just going to times the top of the fraction and the bottom of the fraction by minus 1. So times that, the whole thing by minus 1. Just reverse the signs there and reverse the sign on the bottom. So what we've got now is an expression for cos p bq, but it's in terms of pq squared, and I need it in terms of x squared. And we're told that AB and BC, so AB, that one there, they're both x. And so what we've got to try and do is come up with some expression for PQ in terms of x. And the way to do that is to think about, well, we know the distance from P to Q is the same as the distance from A to C. So let's have a look now at triangle ABC. So that's the triangle at the top here. Okay, and if we can figure out what that distance is, then we know what that distance is. So here we go. And it pops up, there we go. So there's my triangle ABC, and we've got the two sides that are x centimetres each. We already know that that angle there, we're told that that one there, given it in the question, is 30 degrees. And so, again, cosine rule again, we've got that expression AC squared x squared plus x squared minus 2 times x cos 30. And so a bit of tidying up leads that. Now, often you'll find you're seeing questions they use angles of 30, 45, 60 quite a lot, because hopefully you should know, or you should be able to recognise that cos 30 breaks down as a third, and we know that cos 30 is actually root 3 over 2 when you put that one into your calculator. So we can replace the cos 30 with root 3 over 2, and you'll see that, where's my mouse gone? Here it is. The root 3 is there. Notice that the 2 on the bottom here is cancelled out against that 2 there. So that's why we've ended up with this expression here, minus root 3 x squared. And a little bit of factorising, take the x squareds out, so we've got AC squared is 2 minus root 3 lots of x squared. And hopefully you can see this 2 minus root 3 here is appearing in here, so it's looking like we're going in the right direction. The other thing that I'm going to do is, normally with a cosine rule question, the last thing you do is square root it, but if you remember from previously, over here we've got PQ squared, so I'm going to keep this as AC squared because it's the square that I'm looking for. We'll see what's going to happen now. So there's the two results that I've got for my two previous triangles. I know that AC equals PQ, so therefore AC squared is PQ squared. So all we've got to do is just sub our expression into there, so that 2 minus root 3x squared is going in. And so there we go. So now we're kind of very, very close to where we're heading. And the last thing to do, you'll see here we've got this expression over 200, but we've got this thing here out in front on its own. And all that's happening there is if I just do 200 divided by 200, that's the one. And then I've got this thing divided by 200, which would be that expression there. So the last step is just to separate that fraction into two separate bits. And there's the result we were after. Job's a good one.